Hello, welcome to Stars, Cells, and God. My name is Jeff Zweerink. I'm an astrophysicist, Christian apologist, and I'm joined in studio today by Dr. Andy Moyes, and we're going to be talking about the eye and whether it points to design or to evolution. Well, welcome, Andy. I'm really excited about our time today. I know you're an ophthalmologist, correct?
Correct. I'm an eye surgeon. Okay. So after medical school, residency, fellowship, I subspecialize in the front of the eye, the cornea, and the cataracts. Or as my wife would say, I've dedicated my career to something the size of a dime.
Yeah, that would be accurate there. So.
Yeah.
So this is I'm looking forward to our discussion today because this is something that just has a long history in the does God exist? How do science and Christianity interact? Because some have said, oh, the eye is so complex, only God could have designed it. Evolutionists will say, oh, no, this is just naturally how it plays out. So I'm really looking forward to our discussion today. So I'm just going to throw it to you and just kind of start leading us through what are we going to find as we look through this today?
Well, first of all, I thought for historical purposes, I think it'd be great to start with Darwin's shudder, as he shuddered at it. But let's be very honest and give Darwin credit for what he said and not take him out of context. Mm-hmm. He says it's a little quote from Origin of Species, to suppose the eye is with all its inimitable contrivances for adjusting and focusing and distances and emitting different amounts of light, I freely confess the absurd degree that this could have arisen by evolution. And sometimes that's the end of the quote, and that's not fair to him. And we obviously never want to have any discussion with our colleagues or our friends who are on the other side without being fair. And he goes, reason tells me, this is continuing Darwin, that if numerous gradations from a simple and imperfect eye to a complex and perfect one can be shown to exist, each grade being more useful to its possessor, it is certainly the case. He was confident that evolution could do it. And we've seen, just like Darwin had Thomas Huxley be his bulldog 150 years ago, there are many evolutionary scientists stepping up and really to be the bulldog of eye evolution. And we'll look at some of those in some of their arguments.
Well, and it's one of those things I've noticed often that when you initially see something that, with a little bit of knowledge, the result looks a certain way, but deeper investigation, and it can show something different. I kind of see that there with what Darwin, he's like looking at the eye, and it's like, there's just an incredible amount of intricacy here. And he's saying it really does look designed, but his contention was, no, it isn't, and we're going to find that eventually. So now we get to look at it kind of 150, 160 years later. Can you help bring us up to speed in what we've found since then?
Yeah, right. So I think some of what Darwin was thinking, he was in the, William Paley had been the finding the watch on the heath.
Right.
And it's like, and that's the environment that Darwin was responding. Well, we have this mechanism. He proposed a mechanism where he could eliminate the need for a maker, for the watch designer. And that had slowly took off again through his bulldogs. But it's always remained a question. The eye is a very exquisitely complex, exquisitely fine-tuned. And I would like to say it's more like a camera found on the heath than a watch.
And does anybody really dispute that it looks very highly designed and fine-tuned? It seems like that's almost just a piece of data you have to deal with at some level.
Right. And I would say even Richard Dawkins, who spent significant ink on this in The Blind Watchmaker and again in Mount Improbable and again in his autobiography, would say it looks like it, but then he would say it's very clearly Darwinian engineering.
Okay.
So,
that's an interesting term.
Now we have personified, anthropomorphized Darwinian evolution to be an engineer. And it turns out that if that's your perspective, there is nothing that a Darwinian engineer cannot accomplish. That's what I've surmised as I read the literature.
Okay. So kind of take us through what, so obviously we're sitting here talking because I know you think God is responsible for bringing about the eye in some fashion. Dawkins wouldn't. So what do you see as the evidence
Yeah.
towards that, or how would you put the case
let's
forward?
first let's look at what Dawkins said in his Climbing Mount Improbable or the Blind Watchmaker. Is he starts with a model, and again this started from Dan Erik Nielsen in the University of Lund, and a eye patch, a photosensitive patch. And even Darwin said it's no concern to us how that photosensitive cells got to be there. And it's like, well, Charles, that's a big leap in and of itself. That's analogous to where did the first life come from? And origin of life research 70 years after the Miller-Urey experiment still has a huge gap of how do we get these first self-replicating molecules? How do we get the prebiotic molecules? Not to say that we won't find out more, but it's a very difficult hurdle right now for abiogenesis.
So that's kind of what you're saying with the photosensitive cells, that getting photosensitive cells in the first place isn't just like I'll go grab some dirt out there. That's actually pretty technical to have photosensitive cells in the first place.
Right, and that's Michael Behe elucidated that in Darwin's Black Box as he talked about the phototransduction cascade, a very elaborate cascade of chemical responses of how the photon strikes and then how it ends up being a neural impulse.
So in this paper where they're looking at this, are they doing things, I'm just kind of curious, are they looking at saying, okay, we can imagine getting from here to here? Are they looking and saying, okay, these are the actual steps? Or are they just saying, well, we could get some sort of variation, and how much variation would give us a little bit of detail.
So
if you could, what
that
they're doing.
is the critique of their story, is they started out with 8 drawings, which we will have up for those of you who are not just listening but looking at the visual. They started with 8 drawings.
Okay.
And they said, this is how we envision eye evolution going.
Right.
And then how many steps, only making small 1% changes at a time, how many changes would that take to get from a photosensitive patch to a camera-style eye? And they came up with the number 1,829. And then they do sophisticated evolutionary math, which I will take them, I don't understand that. And then the title of their paper is A Pessimistic Estimate of the Time Required for an Eye to Evolve. And they come up with the answer of 364,000 years as we could go from a photosensitive patch to a modern eye. And that, as you know, 364,000 years is a geologic second.
Yeah, that's a blink. Yeah.
Yeah.
No pun intended.
Yeah. So looking at it a different way, different investigators have looked at it and came up with the conclusion that at the beginning of the Cambrian explosion, that eyes independently evolved 40 to 65 times.
Okay.
And again, as we understand the evolutionary paradigm that's been put forth, we're like, that's a significant question. Can you independently evolve something 40 to 65 times without evidence of a predecessor? So there's some questions there.
Well, and that's kind of my question, or and I'm just more curiosity, and may push beyond here, but so there's the question of is this just looking at the mechanical deformations and things that have to happen to be, and kind of saying, all right, if I want to go from here to here, I know I've got to do these 20 things and add them in, or is this looking at, if we have a little bit of change in the actual genetic material, these could cause these sorts of, I'm just kind of curious, what was their approach in looking at it?
Right. My understanding of their approach is as they looked at the physical optical shape of the eye. And again, to make the point very clear, they drew the pictures in advance of what they expected to see.
Right.
And then they said, how many changes would it take us to get there? Mm-hmm. And my critique, and this has been the critique of others, it's like, well, you started with the end in mind, and that's what we call teleology or design. And it's like, let's just be honest, you kind of made more of a case for design than you did for mindless evolution. And I know they wouldn't appreciate that critique, but if you look at the fact that they drew the pictures and said, how can we get there? They began with the end in mind.
Well, but isn't that, I mean, wouldn't that be somewhat justified in the sense that, okay, if I'm looking at things from an evolutionary perspective, I would say, okay, this is where I think it likely started because we see organisms that have these sorts of structures or something in the fossil record matched up with what we see of creatures today. And you say, okay, we know where it is. And then you say, all right, I know I've got to get from there. Almost any trajectory's got to go take that. It seems a little bit justified at some
Well,
point.
in fairness, your point is well made and fair that they're like, how do we get from a patch to a camera-style eye? But it's not really a computer simulation. There's not a randomness allowed and say, oh, if we allow random presumed mutations to happen, it's like how many steps if we pre-program the path.
I see what you're saying. So it's not that this might not be the sequence that ultimately happened, but that's not the mechanism by which evolution works. It doesn't say, oh, how do I get from here to there? It's just going along, whatever happens, and then it just,
right, which
decides.
is a much less directive and much less successful path. Now, as I read Dawkins in The Blind Watchmaker, when he does his, are you familiar with his bugs that he made by computer simulation, which were...
I've heard a little bit about it.
He programmed to make random changes. He did set it up as bilaterality.
Okay.
But then he even says he tweaked the program a little bit to give him more interesting effects. And it's like, thank you for being honest.
Yeah.
Yeah. But you also have tweaked the program to make things more interesting. So, Richard, you designed the program to give more interesting results of these bugs that show up on your computer printouts.
Well, that's interesting because I've talked enough with Fuzz, and he one of the, I think we may have done a Star Cells and God on this, but if not, I know we've talked about it at least in the past. Is that there's this problem you have in a lot of the origin of life type experiments of it's called the fingerprint of God, where that's not the term, the finger of God, where it's like you've got the person who's doing the experiment going in there, cleaning the lab, where how do you separate out is this really a process that would happen from the person saying, I want to measure these things, and so there's just an integral part of the person doing the experiment is part of the experiment in a very real way. It sounds like something similar is going on here in what we're talking about.
Right, but the fact that you've designed it to give interesting results.
Yes.
You're finding interesting results, which is has, pardon me, interesting implications to it. So one of my first points is I read the literature on this, and there's a lot of good literature. And I'll be clear, I am not an evolutionary biologist.
Right.
I am an eye surgeon. I deal with disease. I deal with clarity. I deal with healing to the eye, but obviously I know quite a bit about the eye. That we have some of these, as I called them, the ocular Thomas Huxleys that were rushing to Darwin's defense, saying, yeah, it seems like it would be very hard to evolve, but here's how it is. So Dawkins is the first with his collaboration with Nielsen and coming up with this very quick eye evolution.
Right.
To be honest, Nielsen never called it a computer simulation. He did the calculations to say, how favorable is this? But it wasn't he didn't set it up as a random event. But what's interesting is Nielsen's work has, as you pulled up on the Proceedings of the Royal Society, it's been quoted 400 times. It's been referenced 400 times. And it usually...
Well, I think you sent me a Scientific American article about the evolution of the eye, which is a very popular, and he references that specifically in there. Oh, we can get eye evolution, or we can get this evolution in a million years, so...
Yeah, that is exactly right. It's been referenced as, so it's been computer simulated, whereas I don't think Nielsen and Pelger, his co-author, would ever say this was a computer simulation. It was a computer understanding of what it would get to this teleologic end, even though. But you're right; it's in popular press, and so so the third Thomas ocular Thomas Huxley of the modern age is Trevor Lamb from Australia, and
Right.
he looks like he does really good work in trying to understand. And I don't really want to deal with slimy hagfish and lamprey eels, and so they're looking at, and this is one critique of understanding ocular evolution, is eyes don't fossilize.
Right.
So that's a critique for everybody, and let's be fair to people on both sides of this debate. Eyes are soft tissue, and by and large, they don't fossilize. We may get the bony orbit ossification. We can interpret things from there, but it's not even as good as the inside of the calvarium, the inside of the skull cap, where we can learn something about the brain. We don't get much. So instead of a vertical slice, Jonathan Wells points this out, a vertical slice through the history of life, it's not really there. So they go for the horizontal, looking at the phylogenetic tree.
So what we see here, what organisms that are here alive
organisms
today,
that are here today, by inferred evolutionary descent. And let's be honest, our evolutionist friends do a beautiful job of drawing trees. I mean, they draw trees. I think Stephen Jay Gould would tell us that, notice that there's only points on the trees. We don't have the branch points, but we have the end points.
I think that part is interesting. Just there's another connection, as you were saying that we have recently, scientists have launched the James Webb Space Telescope, and it's been interesting to watch how they're finding all these galaxies. We don't know what we're talking about. It's there's a little bit. There's obviously a hysterical response, which is far beyond what the scientific data is telling you. But the reality of it is we were saying, all right, we know we've got the cosmic microwave background radiation. We know galaxies show up here at this point in time. And they're saying, all right, we're going to extrapolate and say what's reasonable in there. And what gets missed is that we didn't actually have data to see what was happening in there. And as we got data, it was far more interesting than what we thought it was. None of it says Big Bang cosmology is wrong, but it was just it was a lot more complex picture than what we thought. And there seems like there's a parallel here that we're looking at eyes and we're saying, okay, this is a reasonable extrapolation from the limited data we have, but it could very well be far more interesting than what we're seeing.
I think you're right that as creationists, we have nothing to fear in more data.
Yes.
And we're going to get to some of that. There's some the more data has actually come and put a fair amount of kibosh on a very frequent claim against creationists. But Trevor Lamb, Australian evolutionary biologist, does good work, but he wrote this. It was a populist article, minimally in 2011, and we don't usually reference things 14 years old, but if you do a Google search on the eye and evolution, it's top 5, no matter which way you Google it. Scientific
so it's
American.
Still people are reading it, and this is what they're talking about.
Right, so. And it's still this is put forward as evolutionary justification for the eye. And Trevor uses language like, we're going to put the nail in the coffin of intelligent design. And
right.
We proved it. We nailed it. And it's like, did you really? Okay. But then he goes on, we don't have these vertical slices, and we don't really have them in living animals. But what we do, if we look at the larval forms or the embryologic forms of hagfish and lamprey eels, we see things that may look like Nilsson's drawings or what Dawkins has proposed. And it's like, okay, Trevor. And he says we need to do this with caution, but then he comes and does it very vociferously and says, we put the nail in the coffin by this. It reminds you of the old ontogeny recapitulates phylogeny. And I thought that argument had been dismissed, that embryologic development follows phylogenetic development, and it's a way of proving evolution. And I thought we dismissed that, but Trevor brings that back up.
No, that you're right. That I thought that was interesting. I mean, I get the scientific challenge of we don't have these creatures around today. We don't even have some of the fossil evidence of what the eyes would look like.
Mm-hmm.
And so what's the proxy we're doing? I thought it was interesting that you're looking at kind of embryological development, which, it has this longer history of there's an interesting history to that it seems we'd moved past, but it also is still in the discussion today.
So that was it was like interesting that there's it's lay press, but Scientific American, a respectable source for lay press, using such vociferous conquesting language, and then it's reverting to ontogeny sort of arguments. And then the other thing that he does is he uses language like, and we'll get to this, it's the eye is so poorly designed that if this were the engineered, they would be fired. And if it's okay, I'm going to hold that for just a second. So to Dawkins and his Christmas lecture, and you can get, if not the original Christmas lecture, you can easily Google Dawkins and eye evolution. And he's a great communicator. He's a very charming person to listen to. Though we disagree, and that's one of my premises, and it seems to be a reason to believe distinctive, we can disagree agreeably with people. But Dawkins
at least understand each other well in our disagreements.
Right, and we could be friendly, and Dawkins would even say in his autobiography, he says that there is a great rule for strategic satire, and so Dr. Dawkins, my strategic satire may be that you're almost an evangelist, a televangelist for evolution as you make your case. You're a very good communicator. He holds a polyethylene sandwich bag filled with water up in front of the pinhole camera, and now it's a camera. It's a the pinhole eye model, and now it's a camera eye model, and he shows the effect, and it's like, see, it's simple. Any bit of, and I had to look these words up because I don't speak British, gubbins.
I'm not sure that word,
gubbins is any common rubbish or a common person. Any bit of gubbins or gunge will do. And it's like, well, he's communicating to a lay audience, and he's making things very acceptable. He's evangelizing for his form of atheism. And it's like, you're a great communicator, but I'm going to call the technical foul and say, as a cornea, front windshield of the eye, and cataract, the clear lens in the eye, that a clarity is a very unusual natural phenomenon. You just don't see clear. The fact that we have a clear sky is amazing, and you could probably elaborate on that. The number of planets that we understand to have a clear atmosphere is, if they have any atmosphere at all, is very unusual. So,
I would even make a connection that's part of what's going on in Genesis. There's 2 different days of the creation week where what's going on in the atmosphere, moving from opaque to translucent, from translucent to transparent, that is something unusual there, or at least that may be a hint to there being something unusual about transparency. Right.
And so Dawkins' assumption is put any bit of gubbins or gunge, that's his other word there, in front of the camera style eye, and in front of the pinhole eye, and now it's a camera style eye, and anything will do, and we'll let evolution work on it slowly through time. And it's like, well, that's great hand waving, and it almost felt more like claymation to me, is putting a little bit of clear something there, and evolution will figure it out. As a cornea specialist, clarity to the cornea is what I fight for my patients all day long. I have 12 inches of books of one volume, well, it's a 3-volume set of corneal pathology that, and to keep the cornea clear. And I'll just hit 2. One is, and many of our listeners will have this, dry eye syndrome, where the front surface of the eye desiccates and it chaps. Think chapped knuckles.
So
the
desiccate dries out.
Right.
Okay.
Desiccates, dries out, chaps, and then all of a sudden, as you know, in telescopes or in any lens, the front surface is the most important refractive surface.
Right, yeah.
And if it's now chapped or sandblasted, it loses clarity.
Mm-hmm.
There's a very important interactions between the cornea, the conjunctiva, the skin of the eye, and then eyelids. Several sorts of oil glands, tear-producing glands. Corneal clarity is a major deal. And then the other side is dryness on the surface, but keeping the cornea thin and tight and compact and not swollen is a whole nother set of difficulties. And if the cornea swells, it becomes thicker, eventually glass block on the side of your house, and then eventually it opacifies. So clarity of the cornea, clarity of the lens. A lens is an avascular structure also. That's where cataracts happen. These are really unusual optical qualities, not to mention the aqueous humor and the vitreous humor. There's a lot more elegance that meets... Oh, sorry. Yeah, you saw that one coming.
I did. You didn't have to say it. So.
Yeah, I'll even stop short of saying it. There's a lot more elegance there. That clarity is an unusual optical quality.
Well, and I have to hand it to Dawkins. It's a great rhetorical, what is a Glad bag or a Ziploc bag? It's kind of use it, throw it away. It's the junk. It's not that important. I'm willing to bet that if you went to the junkyard, though, and picked up just any random piece of stuff, very few of those, to your point, are going to be clear. It's something that today resonates. Oh, yeah, that's junk. But I'd be hard-pressed to think you find much that is not human-made throughout history that's clear. I'm trying to think through what I see when I'm out walking in the woods and looking in the water, looking at organisms. There's just not much that's clear.
Right. I mean, a drop of water, most water we see.
Yeah, water is, but the moment you put it in something, that something is rarely clear.
And most natural water isn't even clear.
That's
so
the
too, aqueous in our eyes is good. Fingernails, but you're like, well, you wouldn't want to be looking through your fingernail. That was the closest I got there.
Interesting. Okay.
So easy eye evolution is certainly an oxymoron at best, and there's a couple of times I would ask our evolutionary friends to, I'd call a technical foul on them, and I think there's room for more conversation. I clearly see exquisite fine-tuning, and they would put the nail in the coffin of that. And one of the ways they do, and this has been a strong suit to switching to the last topic, is that...
Well, before we get to there, there was I read through that article by Trevor Lamb that you sent. And, there's a part where I'm reading it and I'm like, oh, this is cool. And it's like, oh, this is disturbing at the same time, from a creationist perspective. But he made a comment in there that, as I was thinking and reflecting on it later, he was I think he was talking about specifically about different types of nerve layers, and there's 3 layers in there, and one of these layers was co-opted from here and put into there. And his comment was, that this is exactly what evolution does. And I got to thinking about that and he didn't use co-op, and I would rather actually have the direct quote, but it takes a system here and uses it for some other.
Yeah.
And I'm thinking...
Recruitment is the phrase that I see frequently.
Wherever I see that work in my computer programming or other people could be... It's a sign of an incredible design that somebody could go and recruit something and do something else with small changes. There's part of me that just says, all right, let's just grant that this is all just natural process. It's a very elegant natural process, even in and of itself at some level.
So I'll spell that one out a little bit more. Humans, we have 3 photopigments. Now, 5% of men, and by extension, 1 out of 400 women are colorblind.
Okay.
Now, the fascinating thing is my patients who are colorblind, certainly my a few of my family members would swear they're not. They swear they see everything, and it's like, yeah, your fashion sense is a little different, but other than that, you really do so.
Right.
And it goes. There's a metaphor there that we don't always know what we don't know.
Okay.
But anyway, so we have 3 photopigments, and one of these, and this is actually from an article from an ophthalmologist. Very little of this is written by an ophthalmologist, but I believe at UC Davis. And he talks about when we saw animals come up with 3 photopigments, we also noticed that they had less olfactory lobe, less olfactory nerve. And then the phrase came. So there must have been a recruitment of the nerve fibers from the olfactory lobe into the eye. And I'm like, if we allow for that, then there's nothing that evolution can't do. And so
what you're saying, just that is such a large change of what's going on. We kind of talk about, it's almost like, oh, it's recruitment, therefore we put a term on it and it's easy, but it's actually a very complicated or complex process. Is that what you're alluding to?
Yeah, right.
Okay,
right. To take these neural fibers from our first cranial nerve, our olfactory nerve, smell,
right,
and now somehow meld them into our optic nerve, our second cranial nerve. That's why I use the term claymation, and I am trying to be just a
little bit satirical.
Yeah, a little satirical, but hey, we can do that. We can have friendly conversations and poke each other in the ribs, and I can take pokes back.
Right.
So what I've come up with is when I listen and I read the evolutionary literature, and again, I'm coming at it from someone who knows eyes. It appears that there is nothing that mutations, recruitment, and selection can't do. I mean, there are it's like, well, of course, recruitment did this, and it had a selective pressure, so therefore it did this. And Jeff, my interpretation was, okay, so we have there's nothing it can't do, and from the evolutionist point of view, have we landed on a non-falsifiable
That's an interesting question.
philosophy? And you and I would say things are, well, that's very suggestive. It looks like complex design. And then Trevor Lamb goes on to say things like, well, it would be a simple step to go from an eye, and it needs to have more visual field, so easily extraocular muscles would have evolved. Jeff, there's 6 extraocular muscles for every eye: left, right, up, down, and twist. So you always get one in. That's very sophisticated machinery and neural connections. And most ophthalmologists, other than pediatric or neuro-ophthalmologists, really don't want anything to do with double vision because it's so complex. But if you're going to say, sure, muscles must have evolved because it would be a competitive advantage, and it's just a snap of the fingers, we're back into this non-falsifiable. Eyelids. I have partners who do just eyelid surgery. They're eyelid specialists. Yes, there is such a thing. It's very complex. So,
your question is, you bring that up, and I'm sitting there thinking, okay, I am a Christian. I've been doing science now for well over 30 years. And so one of the questions that runs through my mind is, I'm kind of the opinion there's nothing we're going to find out there that doesn't align with Scripture. Yeah. In some sense, that's an unfalsifiable mindset.
And I accept that.
So I wonder how much of this is, instead of getting hung up on the falsifiable, unfalsifiable type thing, that recognizing that at some level we're all advocating for something. And we're all looking at the science and asking the question. And so instead of the science being the decider, if you will, that what we're saying is, I've got a worldview. I've got a way of looking at things. And I'm continually asking, can this fit into my worldview? And, Trevor Lamb, Dawkins, they've got a worldview, and they're looking at things, and they're perpetually asking, can this fit into my worldview? Can this fit into my worldview? It's not the science that is the arbiter of that, because we're all looking basically at the same scientific data and saying, I think it works better aligning with Christianity. They're looking at saying, oh, it works better with there being no God. maybe we need a different set of tools to evaluate worldviews than what science has to say. Well, I'm curious your thoughts there.
I would agree. Let me take it a slightly different direction. My observation was very simply that is a critique of me as a creationist, that this is a non-falsifiable.
Okay.
This is a non-falsifiable position because God did it. And it's like, and God of the gaps gets laid out against us. And I'm like, okay, I see how that could lead to disingenuous science. And
Right.
I will accept that critique and I will sharpen my thinking to try to avoid God of the gaps arguments. But what's become obvious to me as I've studied evolutionary eye literature is there is a mutation of the gaps, mutation,
Gotcha.
recruitment,
Yeah,
and
I see what you're
selection that we're being presented with presented as a non-falsifiable paradigm. And it's like,
So you're
okay.
basically asking for the same sort, accept the critique and say, hey, let's think more carefully about this than just saying, being a little cavalier about what evolution can do, if you will.
I'll be careful. And
Yeah.
now, Jeff, I'm going to get crazy.
Uh-oh.
And I'm going to say, wouldn't it be great if we could have conversations?
I agree.
I mean, wouldn't it be great if we can have? I realize it's 2025 and conversations don't happen that much. There's more snark that goes between camps, but it's like, I don't know. I'm just naive enough, being from the Midwest, to think that I can sit down and have a friendly conversation. And I'd love to buy Richard Dawkins any bottle of wine he'd want, and we could have an off-the-record conversation because I would find him fascinating. And I would love to know his take on things. And
I think there would be cool things you would discover. Obviously, places where you're going to disagree, but he's a bright guy. There's things to learn. I think that's a great idea.
He's led a fascinating life, and I would love for him to take some interest in my thoughts. He doesn't have to agree with me. Well,
let's move back. Let's go on to our final.
The final is this has been. Jonathan Wells in his books Icons of Evolution as the poorly designed eye has been an icon of evolution for a long time. And so let me spell out for our listeners exactly what that is. It's a phenomena called an inverted retina. And without going into inverted, everted, the idea is that the eye is like a camera, cornea, front lens, a diaphragm is the iris, and that's all the iris is. Your pupil, all the pupil is a black hole, not your type of black hole.
Right, I got you.
Is a black hole that lets the light in.
Right.
Smaller and bright light gives better depth of focus. Larger, shallower depth of focus in dim light. And then there's a crystalline lens that lives behind there. And
that's on the back of the eye.
That's the crystalline lens is right behind the iris.
Okay.
It's immediately behind
the
iris.
Lens. No, yeah, I get you. Okay.
So light is transmitting through these optical structures. And now as it transmits through the vitreous is the clear jelly, it goes on to hit the retina. The retina is the photosensors, the film, if you will.
Okay.
And this is where the critique comes in, is the first layers that the light approaches are ganglion cells. Those are the transmission lines back to the brain. Bipolar cells, those are communication cells back to the actual photosensors, which are rods and cones. So the light has to go even further through these ganglion cells, bipolar cells, and then there's some horizontal cells, amacrine cells as well, to get all the way, and they have to get to the far distal end of the rods and cones to get to the actual photopigment that absorbs the photon.
Right.
And
so you've got all of this clear stuff that it's going through, and then the last part of the journey is all of this non-clear stuff before it's actually detected as a photon.
Absolutely.
Okay.
So that's the critique and then the words that come out is and I get a little confused which one was Dawkins and which one was Lamb, but they all say something like, if you were an engineer, they'd be fired for designing an eye like
I
this.
know Trevor Lamb said that. So.
Okay, and then maybe Dawkins they'd get a D-.
Right.
It's somewhere in in that category that it's just like, see, we told you this is poorly designed, and that's because evolution doesn't do a perfect job. And it's just kind of a holdover, and that's how it happened, and that proves there's no creator. And it's like, hold it, wait for it. Let's hold things a little more open-handed. So there's been a fair amount of research that's come about recently. And this is a 2022 article from Current Biology. And again, Tom Baden, and one of the co-authors is Dan Eric Nilsson, the same Nilsson who did the non-simulation computer simulation.
Right.
And I don't mean to disparage him. It's just he did good work. I just don't think he's accurately quoted.
It was co-opted for something other than what he actually did.
Maybe recruited.
There we go.
And it turns out that the actual quote is, in terms of performance, the vertebrate eye is close to perfect. And that is a direct quote.
Okay. So that's a remarkable statement because, I mean, even when I started getting into apologetics, which is coming up on 40 years ago now, the eye's a bad design, that had been out there for a long time. I mean, so all of this stuff about how bad it is, to have people saying it's a near perfect design, that's a remarkable shift.
It is a remarkable shift. If you'll allow me a minute, I'll explain a little. I'm going to give you, I believe, 4 reasons why that they turn and say that. One, the retinal rods and cones are some of the most metabolically active cells.
Those are the ones that are
those are the
photoreceptors,
photoreceptors, right? Those are the ones that are inverted and further away from the light.
Right.
They're very close to a nutrient system, the retinal pigment epithelium, which is essentially their minder. It feeds them with nutrients, and it's constantly repairing the cells and regenerating the rods and cones.
Right.
Below that is a big capillary bed called the choriocapillaris.
Okay.
So these are very metabolically active because
which means they're going to generate quite a bit of heat, I presume.
Yep.
For an eye, I mean.
Of course, I am talking to a physicist.
I'm
I'm sure they do, but and as a physician, I'd say they need lots of blood supply. They need They need lots of carbohydrates, oxygen.
Okay, so you need lots of fuel and heat.
Yeah, right.
Metabolically active things require a lot of care because you got to feed and dissipate waste products.
So step number 1 of saying this is a near perfect is saying they're right there. It's right there by this retinal pigment epithelium. The retinal pigment epithelium is black pigment epithelium.
Okay.
And so that's also one of the barriers that absorbs light and keeps it from being stray light. We'll come back to that.
Okay.
We'll come back to that concept. So there's less stray light in the eye. Not zero, less. But so the metabolic support for these cells is right there. The photoreceptors in their distal position is closer to the metabolic support. Another thing that they came up with is in an eye, a camera-style eye, there has to be a distance from the focusing lens back to the actual focusing point.
Right.
And their point, not mine, is by having this inverted retina, it allows it to be that much further away from the focusing point so that it can focus.
Okay.
Rather than in cephalopods, mollusks, cuttlefish, octopus, cuttlefish, and squid, it's all with their everted photocells. There's not nearly as much focusing distance.
No, that's fair. I just know even from building telescopes that I have that the longer the focal length is compared to the size of the aperture, you get better. Your mirror works better, and you get less things that cause aberrations and make it hard to figure out what's going on. So you're saying that sort of phenomenon is going on inside the eye as well.
That phenomenon is going on here too. And what's fascinating is little aside, they look at zebrafish embryos that are, you ready for this, 150 microns long. And they're seeing this same arrangement, and it's like, okay, I don't know quite what to think about that, but it's like, who looks at a zebrafish embryo eye that's, 1/7 of a millimeter long?
Right.
But I thought, well, good for you. I'm glad you're doing really good work. So we had metabolically supported, we had further focal length, and then there's two really important things. So bipolar cells going through the ganglion cells, going through the stacks of mitochondria in the actual photoreceptors, the rods and cones. It's like, well, that can't be good. And then it's like, well, it turns out that those are very accurate focusing. It's almost like a fiber optic cable that takes the information from the surface of the retina all the way down to the actual photopigments.
Right.
And they're like, hold on, this may actually be a more elegant design. Is that now in ophthalmology, the one thing we abhor is stray light. Stray light we call glare.
Yeah,
Okay?
I see where you're going.
Or as I tell my patients as we're discussing potential cataract surgery, that it's think dirty windshield. In the Midwest, we have snowy, icy, and there's lots of salt, and we get that salty scum on our windshield. Light hits it, scattered light. We call that glare.
Even just put raindrops on there. Same sort of phenomena. You run your windshield wipers just a little bit, they spread that all out. If the sun's coming at you, instead of it being the sun, it becomes this white sheet across your windshield, which is hard to see.
Scattered light are non-parallel or perpendicular, however you want to think of it. Light gives erroneous information. So now we have these bipolar cells and stacks of mitochondria. By the way, Fuzz wrote a great article on the website that lays some of this out. They act like a fiber optic cable. So the actual light has to hit the fiber optic cable, which is analogous to dropping a ping pong ball into a paper towel roll.
Right.
It's got to hit it, and if it hits it from the side, very few of those ping pong balls are going to come down the paper towel roll. Some will. There's always some scattered light because but Nilsson and Baden do a good point of saying it's really not, the scattering is not as much a problem of the retina as it is just a feature of the nature of light.
Oh, yeah. No, this is on the telescopes and detectors I work on. That's a problem we have to deal with. We look at it, where it shows up for us is a little different. It's like we want to gather as much light as possible because the more light you get, the higher sensitivity you have. But one of the problems you run into is that a lot of that is coming in at oblique angles. Not only does it now make it hard to focus or figure out where the light's coming from, but it also impacts the timing of it. Because those things that are coming in more obliquely have taken longer to get there. And so not only does it affect your actual resolution in spatial resolution, but it also affects your timing resolution as well.
Okay. And
so
at the speed of light, a little bit of time.
I'm just saying, you said this, I'm like, oh, that's cool that our eyes do that.
Yeah, this is actually, I knew we were going to have some of these conversations about, because we're both light sort of guys, so it's like, hold on, this ends up being a very elegant system to, in the everted retina mollusks, they're typically more in they're in the ocean, so there's less light to begin with, and there's more of a need to pick up any photons,
kind of light,
every kind of light, looking for prey or predator, you know, and I get that. In ours, we're more exquisite and fine-tuned, not bouncing or stray scattered light.
Right.
And then the last thing that they point out I think is absolutely fascinating, and I frankly hadn't really put this together before, but these horizontal cells and amacrine cells, there is neuroprocessing that is happening as a sort of a subunit right there in the retina.
Oh, really?
Yeah.
So this isn't just transmitting information.
No,
back to the
it's
eye.
not.
It's actually pre-processing.
It's not one,
right?
Wow. It is not one-for-one data going back. There is a pre-processing, and actually I did some research in this in medical school about on and off electroretinograms, ERG, and what you there's certain cells that are really set up for edge detection. And that's what's happening in the retina with these.
Wow.
There's 2 plexiform layers, 2 processing layers, and I'm like, oh my goodness, the elegance of doing this sub-processing before it even gets back to the lateral geniculate body, occipital cortex is amazing on off. So the example that they use in their paper is noting a bird against a black sky, a blue sky, is that we're able to detect differences. That the brain notes the blue sky, but it's the things that are different. And that a lot of that has happened. It's been interpreted in the retina. Now then, like I said, all the way to the back of the brain for visual interpretation, and then for understanding perception happens in the next step forward in the parietal cortex of the brain.
It sounds like, and we're not even going to delve into this more than what you just said there, is that not only is getting the eye to work and transmit the information out reliably and robustly, but the processing of that information in the brain, I imagine, has a lot of, to use a term we've used way too often today, very interesting features to it as well.
Yeah.
Because I just see that based on the work that I'm doing in the lab, getting information out and figuring out what the information tells you is a complicated process. And so what our eyes do all the time without getting tired, well, largely without getting tired and almost subconscious thought about it, it's an incredible amount of processing.
Right. And it's pattern recognition.
Right.
That's what you do. That's what I do. As a physician, I look for patterns of health and disease. But I can also tell that that's a camera right there, just in my peripheral vision because of the processing. So I do remind my patients sometimes that eyes are the cameras, but our brain is what perceives the information. Well, and that's a whole nother elegant system in itself. And we'll leave it at that.
Yeah, well, this has just been a fascinating discussion, and we could probably go on a long time, but I do think it'd wrap up here. I'm just from an apologetic perspective. I mean, we've talked about is eye evolution as easy as they say? We've talked about the clarity and how that's an uncommon feature we kind of take for granted. We've talked about whether the eye is a good design or a bad design. So from an apologetics perspective, as we want to go out and talk to people, reveal God in science, as an apologist, how do you use this? How do you think about it? What do you do with it?
I suppose there's the defensive and the offensive without being offensive role. So the defensive is this is we've literally had our nose smeared in this is poor design for a long time, and I think there's a great take-home message. And again, I gave you the quote: "Nearly perfect," that I appreciate the humility of an evolutionary biologist. Now, he says that it got there by evolutionary biology.
Right.
I appreciate his humility to say that, especially that is a counter to what the paradigm has been for the last, 50 years or so, that it's been an icon of evolution. So on the defensive side, we can turn that and say, well, what we didn't know, everybody had an ignorance of the gaps. That's not a finger-pointing thing. There was an ignorance of the gaps, but as more information comes to light, another nice pun, is that we are able to understand it more, and we're actually able to see the elegance of it. So I'll be honest with you, Jeff, even as I was preparing for this, because I'm not an eye evolutionist, but I understand eyes, there was part of me that was eager to come out and have a rock-solid case against eye evolution. And I thought, I really had to search my own heart and say, no, be honest, look. If you don't know, it's okay not to know, and we can hold things open-handedly. And I think that attitude will go a long way with our conversations with naturalists. And it'll also go a long way with our friends who are young earth creationists who like to poke at us a bit too, that we can say we don't know, but that we're confident in the goodness of God. We're confident in the sovereignty of God. And as this comes through, that we'll understand it better. And it's okay if you don't share my paradigm. But can we have conversations? I'll hear you. Will you hear me? And I promise not to come off as smug.
Well, thanks, Andy. I really appreciate it. It's been a lot of fun, and hope you've enjoyed our conversation today. Thanks for joining us on Star Cells and God. Want to encourage you, go down into the comments below and join us in the discussion. Remember, like this video, subscribe for more content. We drop new episodes of Star Cells and God each Wednesday. They're available here on YouTube and on your favorite podcast app. Make sure to share this video with a friend, maybe somebody who disagrees with you, and have a great conversation about it. And while you're doing that, remember, the more we know about science, the more reasons we have to believe that God is the creator, he says in the Bible.